Next, we have another special segment of this conference, and that is the second guest speech of the International Conference in Data Science 2021. To introduce our second guest speaker to the audience, I would like to invite Senior Lecturer of the Department of Statistics, University of Colombo, Dr. Dilshani Thisera.
Thank you, Seka. It is with great privilege that I introduce the second guest speaker of this international conference, Professor Umashanger Thayasivam. He is a professor in statistics and data science at the Rowan University, New Jersey. Professor Thayasivam earned his doctoral degree for his research work on mixture distribution at the University of Georgia. He is also an alumnus of the University of Colombo, Sri Lanka, with a Bachelor of Science in Statistics. His many research interests span the topics mixed distribution, robust estimation, high-dimensional data analysis, statistical data mining, and biomarker discovery. Professor Thayasivam is to be appointed as the chair of the Department of Mathematics, Rowan University, from the 1st of July 2021. He was also awarded the Teaching Wall of Fame Award for his excellence in teaching in 2018. Professor Thayasivam has an extensive experience with collaborating scientist-engineers. He has several journal publications and numerous conference presentations. He has been principal investigator for several internal and external grants and collaboration, including the recent data mining project with Bristol Myers Squibb Pharmaceutical Company. This was just a glimpse at Professor Thayasivam's distinguished career in statistics and data science. Today, he has joined with us to share his wisdom on the topic, Future of Data Science, Quantum Computing. Ladies and gentlemen, please welcome Professor Thayasivam to address this virtual forum.
Okay. Good afternoon, good evening, good night, almost 1 a.m. here. I just want to make sure that I can share it. Is that loading for you all? Can you all see my screen or not?
Yes, so we can see the screen.
Okay, good. Okay, so first of all, it's my pleasure to be here and thank you for the invitation. And this is a special one for me because, I'm, as Dilshani said, I'm an alumni of this school. So first of all, I would like to, acknowledge the Vice Chancellor and the Dean of the Faculty of Science and Head of the Statistics Department, as well as the distinguished speakers, Professor Emerson and Professor Chakrabarti. Also, all other, distinguished guests joined in the event. It's my privilege to be here, and also I would like to thank the organizing committee of this conference event to just give me this opportunity to share my knowledge. As Professor Emerson, I'm going to share something more like a high-level talk about the future of data science. So I'm not directly, translating my research area. This is more like an area I'm just become fond of, and then just start, reading and working on it. But I thought this is going to be one of the area which definitely everybody should know of. So that's the reason I'm just going to share this. Okay, so as an outline of my talk, I'm going to give some introduction overall, and then I will give the motivation, and then I will talk about what is quantum computing, and then I will also talk about the application in data science, and then I will give some concluding remarks. And depending on the times, if time permits, I will try to share few of my recent projects. So Dilshani already gave me a nice introduction. Thanks for that. But I just wanted to share about me. I'm just did bachelor's in this institute 20 years ago. So I graduated 20 years ago, and then we are celebrating the 20th anniversary of the statistics department. So as you'll imagine, we are one of the first batch in this sort of the new setup as a separate department. So start from there, and I just did my master's and PhD in University of Georgia. Then I joined the Rowan University 2009 and became the professor last year. And then as starting from July 1st, I'm going to become the chair of the department. So that's the background, and it's a very pleasure and privilege to speak here, because I know in the audience, my teachers are there and my friends are there, like my collaborator students are there, and my students are also there. So it's a very privilege to be here. The picture here is a new building, right? I know you guys now just recently have new building, so I couldn't find the old building picture, just put it there. Okay, so as a motivation, let's see. As we advance as species, there are a lot of things, right, that once seems to be impossible a century ago are really evolving. Right now, we create more than 2.5 quantile, like quantile mean 10 to the power 18 data bytes of data. And we expect this to grow about 3.5 quantile by 2025, especially with the 5G and then the Internet of Things. I don't know how many of you all know the first electronic calculator is built in 1960s, about 60 years ago. Now, within these 60 years, you can imagine how things just evolve. So classical computing even become more exponentially faster and capable of handling multitasking. However, that doesn't mean everything we can handle is already there, right? So it is envisioned that the quantum computing will accelerate us in the future of impacting data science. So we are in the data science era. 21st century is a data science era. However, right, there is also a talk, like it's there forever, but recently it's just popping up. This quantum computing power and the speed is going to help us or hurt us, right, to handle the big data challenges. So that's what I'm going to talk about, sharing some of these information. So the quantum computing is not something new. The scientists, using for the past 120 years, it's just coming from this quantum mechanics, right? It's one of the successful stories in the modern science. Without that, we wouldn't have, the marvels of atomic clocks, computers, lasers, and the GPS, the global positioning systems, and the MRI, and many other. So what is quantum computing? I'm not going to go in a technical way, but I'm just going to give an overview of just what it is and what it differs from the classical computing what we have, so that you understand better when we connect to the data science. The fundamental of component of this new technology is what they call the qubit. It's a quantum version of the classical bit. As you all know, the computers we use in a classical bit has values 0s or 1. And joining these bits, we just create this computer representation information such as letters, numbers, and so on and so forth. The quantum bits, by contrast, can have a value of 0 or 1. At the same time, this quantum concept called superposition, in which an object can exist in 2 or more states at once. This paradox is known as Scarface cat, in which a fictional cat is simultaneously alive and dead. So it's sort of a, sometimes it's not easy to grab, but the concept-wise, as you all know, it's not just a regular classical bit, it just goes beyond. A quantum bit can have in the same setup in 2 different ways. So the quantum computers can consider a lot more information. They can gather a lot more information at once, and it can increase the calculation power also exponentially. So some of the vocabulary, it might be slightly technical, just this slide, but I just want to throw the jargon, because you need to know, like whenever if you start reading in the future, these words are going to come across. So I just want to give a brief overview. So the qubits, it's not bits. We are do calculation with quantum bits rather than the digital bits. That's the first thing you need to know about the quantum computing. And superposition means objects can be in more than one state at the same time. And entanglement, when qubits are entangled, they form a connection to each other that survives no matter what the distance are. And this conceptual, the notion of quantum computing is a difficult task. I become just fond of this. In 2018, I went to RMIT University for as part of my sabbatical, and there, during that time, I heard about this news about silicon microchips, the quantum coding of silicon microchips developed by the RMIT University, which is sort of one of the fundamental for the quantum world to just in the modern area. Now, just to give a background, as you see from this image, the classical computing, you have just zeros and one, whereas the quantum computing, you have, you can see the superposition could be, you could be anywhere at the same time, like which can be stored anywhere as a 0 and 1 at the same time. Now, just let's say 300 qubits. A smartphone, what we have currently in your pocket, has more than 1 billion bits, not qubits, just the bits easily. So 300 qubits is not a big one number. However, if you consider the number of combinations that 300 qubits can just bring you, is going to be 2 and then followed by 90 zeros. So as you imagine, that's the main advantage of qubits, because it's going to produce so many combinations of it. It's almost like the simple discrete math, you guys learn, or permutation combination you learn. If you are sitting in a table, 10 people are sitting in a table, how many ways you can arrange is 10 factorial. But as the number increases and increases, you get this larger and larger. That concept of, the overall combination just become the issue. Now, let's look at a toy example. Suppose we have a set of 100 records, and we the task of computer to find one, let's say the Gypsies album in the stack. Classically, a computer would need to examine each individual record and make a yes or no option about whether this album we are searching for based on a given set of search criteria. So you will sort of send a query, right, SQL, and the computer gives you an output. So in this case, the query is what? Does this record satisfy my set of criteria? Right? So that's what the query. And finding the record in the question could take only a few queries. It is near the top of the stack. However, you might, if you are not lucky, so you may have to just go all the way closer to the 100 queries to get that. So it's almost like, in simple statistics, we call this uniform distributional setup. So on average, you would expect locate the correct record with about 50 queries. If you have 100 queries, right, on average, half of the total number in the stack would be necessary for us to just get that importance. A quantum computer, on the other hand, right, would locate the Gypsies album much faster. This is because it has the ability to analyze all the records at once. Not quite like all the record at once, but it's slightly complicated in that sense. But you can think like that, where the so-called superposition is we are like one can in the same level at the same time. So with this property, the number of queries need to be located the Gypsies is only about 10. On the other hand, as I said earlier, it's about instead of 50, it's 10. As this number increases, so this difference is going to be, difference in use. So that's where the exponential advantage of quantum computing is just going to come into play. As well, some of you all might, identify this. This is the image of the telephone book, right? So if you need to find out a name, a particular individual's, phone number, then the book is arranged in the order from alphabet. So you can relatively easily locate the alphabet and then try to find the number. However, suppose if you need to look at the phone to find the number, right? So suppose you have a number, right? So based on the number, you want to figure out like who that individual number belongs to. Then mathematically speaking, if there are n numbers, it's similar to what I said earlier, you need to go through about n by 2, right, pages to find out, what's that. However, that's a classical setup. But however, if you do the classic quantum based, so the Bell Lab scientists suggest, right, and then they prove that you need to only look at the square root of n. So for 100, it would become 50 and 10 in the previous example. Let's say you have 1 million records. Then for the quantum setup, you need to only look at 1,000 as opposed to, half of million, you need to look at if you are using the classical computer. So as you see the advantage of just moving into the quantum. So what is quantum advantage? And in fact, there is a terminology people use, right? If you have read the, the recent news channels, they use this term called quantum supremacy. So what is quantum supremacy? A situation in which quantum computing has allowed for something to be computed more efficiently than would be possible for a classical computer alone. So a quantum computing and classical computing together is just much, much, much higher than just the classical computing. Now, how do we demonstrate conclusively that this is, more efficient? That is where we are still struggling. There is no clear-cut answer. You can sort of claim, I think this is the best form, but it's sort of sometimes comparing apples and oranges. So we cannot really compare. So that's where like my focus here is to give you an idea about what are the possible pathways we can just go over and how do we incorporate the quantum computing into the data science. So if the classical computing fails to respond, at the same time, quantum computing is just achieve the goal, then we can claim the advantage of this quantum supremacy. So the first part of this quantum supremacy, whether it's achieved or not. So in 2019, the Google's quantum computer did a calculation in less than 4 minutes, and the Google claimed that it would take the world's most powerful computer at that time, like the IBM Summit is the world's powerful computer, and they claim it's going to take 10,000 years to do it, right? And so it's about almost 158 million times faster than the world's fastest supercomputer. And here is the Google CEO. You can see this is the quantum computer, like it's just. So the Google proclaimed that it has achieved the quantum supremacy with its computer, the quantum computer known as Sycamore, quantum computer that can solve complex algorithms unsolvable by any computer at the end today. That's what their claim is. Is that really true? Maybe or maybe not. IBM, which was the superpower at that time for the regular classical computer, they quickly refuted the Google's claim. So IBM said that the Google did not correctly factor into their computer summit, right? You can compute the summit, or you can configure your summit in such a way so it's going to allow us to keep up with the Google suite. And they said it's going to be only take 2.5 days as opposed to what the Google claim as 10,000 years. So they said it's going to only take 2.5 days. Even if it is 2.5 days, if you look at it, the Google's claim it's only 4 minutes. And on the other hand, even if what IBM is said 2.5 days, right, with correct configuration, it's still much different. So definitely Google has achieved something remarkable. But whether it's actually the so-called quantum supremacy or not, it depends on how you define. However, as you will see, there is definitely quantum computers is just. So the quantum advantage and quantum supremacy, these are the two terms people use interchangeably, but there's a slight difference. Quantum advantage means the quantum computer system can perform much faster than the classical computer. So in the previous example, the IBM claim it's on 2.5 days, whereas the Google's quantum computer claims in 4 seconds. So that's like much faster. So you can say it's quantum advantage. On the other hand, quantum supremacy means it's accomplished by a quantum system that has computing power so great they can perform calculation, whereas none of the conventional supercomputers cannot do that. So that's where we can claim it as quantum supremacy. So this is just a background of quantum computing. Then one last thing I wanted to say before we get into data science application is there are a couple of other breakthroughs also came in recently. 6 months ago, a team of Chinese scientists claimed to have constructed a quantum computer that can perform certain computation almost 100 trillion times faster than the world's most advanced supercomputer. And they claim this new prototype can process 10 billion faster than the Google's prototype, which I show you earlier. So that's again sort of another breakthrough. People found that quantum computing might be able to use it in the future. And the Denmark University, they develop a light-based quantum computers, which increase in the number of qubits. Because one of the challenge we wanted to do is as we need to increase the number of qubits. Currently, the maximum we have is 53. That's what from the IBM. So the Denmark University is now developing something which they claim that it can increase the number of qubits. And of course, recently IBM with University of Chicago, right, they turned the largest quantum computer into a quantum material, so they can use this to reproduce and then just go beyond that. So these are some of the amazing quantum breakthroughs happening recently. So the hope is it will bring the liberation and the freedom to the world of science, right, today. So that's a background of quantum computing in a snapshot, not technical way, but in a general sense. And then now I just wanted to show you what are some potential applications, not only these parts, but I just want to show some of them where the quantum computing for data science. So I'm going to talk about each of them. So I'm not going to just go into the slide. I'll let me each in one by one. So the most important part of applications of data science where the quantum computing might become an important role is the data privacy or cybersecurity, or even in a big extent, you can say the cryptography. So this quantum computing, the introduction of quantum computing is going to be currently with the classical setup. We have built all the security, right? Every security we built so far is based on classical setup, the classical computing setup. So there's a belief that this quantum computing could be a threat to cybersecurity. Cybersecurity research data scientists are worried that quantum computer could break the most modern cryptography. Today's RSA encryption, right? That's the most common encryption people use, right? The reverse Shamak encryption, where they use both the private key and public key, right? As most of you might be familiar with this. That's the encryption they use for any of the most sensitive data, which is based on 2048 bit numbers. So some estimation, the expert says the quantum computers currently what we have, like need as large as 70 million qubits to break the encryption. So somewhat, a good thing for the time being, because the maximum we have at the time being is 53 qubit. So it's a long way to go. However, right, it may not, right, as you imagine, I show you like in the 1960s, we had the electronic calculator, now we are a we. So things can go in a much fast manner, right? So the pace of quantum research continue to accelerate. So perhaps in next 3-5 years, who knows, right? We might be able to just do it in a quick manner, and then, it can just also break it. In fact, there's an example, right? Google and the Royal Institute of Technology, Sweden, right? They did some research work and they highlighted, this came in the MIT Technology Review, that a 20 million qubit computer could break a 2048 bit number in a more 84 hours. So that means, if you spend 8 hours, you can break any sort of a encryption code, right? If you have a 20 million qubit. So things are just going. So there's a risk of the cybersecurity if we are going to use that. Now, another important aspect I wanted to just also share. Now, we all use these so-called random numbers, right? But the random numbers we are using is from the classical setup. So the random numbers we use are not really a random at all. While seemingly random numbers have been generated from classical computers, right? But it's actually based on mathematical formulas. So given enough time and capacity and a computer system, right, which really want to hack, you can unlock the pattern of these pseudo random numbers. So this become a very, very, potential problem for high security, right, including military, cryptographies and so on. On the other hand, the theoretical study says the quantum system, however, have the ability to generate the true random numbers, right? That's the fundamental principle of the randomness from the quantum physics. So that's going to be another future people are thinking, right? So if you generate the random number from this quantum computing, so even if you build a system using using the quantum system, that cyber threat might be less compared to what we currently have. Now, applications of data science, another thing is sports. So unfortunately, I'm a big fan of cricket, but I couldn't use any recent photos of Sri Lankan cricket, so I had to use the old one. I don't want to go beyond that. You understand what I mean. But as you all know, in sports, like people use the data science. Here I share different pictures. So like one of the general cricket analysis they use, or any other sports. But in US and all, they do study about individuals, right? Especially in baseball, there's a lot of data science application just about individual. When they do like every action, they just just monitor. So that's programmed. So they have just convert that into do a study info. And in fact, the picture on the corner in the right is used to be a data scientist for Indian cricket, right? With Chris Gale. So the data science plays an important role in cricket too. So, however, like maybe we may have to do a different things, fundamental things in our cricket, but that's a different story. But just the sport. So just to share how the data science could be quantum computing play a major role. The tactical analysis in sport is a challenging part, right? Especially in team sports, which require not only data accessibility, but also the ability to explore the dynamics of this data to measure them constantly changing conditions. So the quantum computing is believed to break the limitation of conventional information provision. They can enable more vision and knowledge accelerator. Right? Especially, it's going to be beneficial for the fast-paced team sports such as soccer, football, and cricket. Right? When I say football, this is like your the American football. So it's slightly in different, like your soccer is what we we all use football there. Okay, so that's sort of the background. So we are not currently using quantum computing in a big scale. Quantum computing is still everywhere in a research study, right? They haven't really explored everything in application oriented, but people are just trying different aspects. So definitely, this is going to have a huge role in sports. Right? Just to share one quick thing, in 27 edition of the ICC Champion Trophy, they just put a bat sensor, which they place it on the top of the bat handle. They just put a sticker. So from that, right, they can just measure the power of the bat and all sort of different things. So there is already some sort of a computing, advanced computing is just going on to translate about the knowledge of what's happening. So definitely, right, in the future, it can play a huge role as well. Now, another applications of data science with quantum computing is, especially with big airports. Of course, now the things are getting much and better, like after this pandemic. So hopefully, this is going to become a huge area of research people need to use, the airline route planning, right? So you need to just plan properly just how to put the airline. So for that, right? So research have shown from some sort of a like a case studies based study, the quantum computers can solve practical problems that traditional computers cannot solve in a reasonable amount of time for the airline route planning. The quantum computer could calculate all possible routes at once using an algorithm they developed called quantum approximate optimization algorithm. So they call it QAQA. According to the researchers, a simulation of 25 quantum bits would be good enough to solve an optimization problem to computer, right? To benefit of practical use for a given airport, right? That should be good enough to just handle it. Another area of research for statistics where the future could be is financial service and fraud and risk reduction, right? So the financial service institutions are exploring quantum computing to enable calculations that are not possible with traditional computing technology. So experiment could be in terms of targeting and predictions or trading optimization and risk profile. The optimization is going to be very important part in terms of quantum computing. As you all know, now in the modern era, like with new data science, the deep learning and all, a lot of optimization involved, right? The neural network. So there is already a quantum neural network that people are developing where this optimization can be solved in a much faster and in a computationally efficient manner. So that could be a future also for the financial institution to just make it more stable and then targeting and predicting in the right manner. And this can help to just use the risk management tool. This is just a study. They show like how much you can save the revenue and potential by benefiting from moving to quantum computing, your usage of quantum computing in the areas of feature selection and then portfolio management, credit scoring, right, and risk analysis, and furthermore the fraud detection and all. So as you'll see, right, there's a huge potential of revenue saving if you just move in that direction, because a lot of frauds and all, right, we might do just in a timely manner. Another important, interesting area, right, people found is the delivery logistics. In countries like big countries like the US and UK and all, the delivery logistics is, like especially when you're ordering in Amazon or any other big vendors, they have to just deliver it through different companies. So one of the two popular companies is UPS and FedEx. So how quantum computers can just help us here for the supply chains and transform logistics? In traditionally, they believe the UPS drivers almost never turn left. So when they drive, right? So as you all know, in US, as opposed to the driving is opposite direction to Sri Lanka, right? So for decades, what the drivers, they understand, right? So you shouldn't turn left because it will take time. So they will try to just go in the different direction to just, come across, turn right and then just take all the way to that. That's how they just usually take, because that will be more idling, less idling time, right? And then the greater fuel consumption if you just do the other way around. But it's not always reliable, right? So in 2012, the UPS began using a navigation called Orion, so an on-road integrated optimization navigation. So it's sort of using a route to optimization algorithm. So now with quantum computing, Orion can just provide more mathematical justification for what drivers had already guessed, right? So they can build an efficient right turn loop. So I am in an eastern part of USA called New Jersey. We are like when you're driving, they call something called the jack handle. So they put a handle on the right side. So if you want to turn left, you are not going to wait in some places to just turn left in the signal. You always turn right and then stay there and then. So that will just overall the traffic flow is going to control. So things are already in build, but with the classical computing, but with quantum computing, this might even go in further, right? So you might be able to get a better optimized pathway. So this can save so-called the million gallons of emissions, right? And also will save cost each year. So quantum computing could speed up the delivery process, right? Also help to build more reliable or resilient supply chain as opposed to the replanning and reallocation. So that's again another, especially there could be unexpected shutdowns or late shipments, right? Or cancellation. So these are ways to make use of quantum computing to just go further. Okay, so there are applications of healthcare. I will just go directly. In the healthcare industry, right, you could use also quantum computing, right, to just get the diagnosis assistant and precision medicine and price. All those different areas where healthcare is another area where the data scientist plays a major role. And the Case Western University is using the quantum computing, right, based algorithm to improve MRI scan. So that's another area of research is going on. And the pattern matching is another area where it just become an increasingly viable. So the Volkswagen car company, they are using the quantum routing mechanism. So they are trying to give all their Volkswagen drivers just giving the traffic condition 45 minutes in advance, right, based on what they can predict the behavior system. This is still at testing phase, but there is a study going on to change using the quantum computers to just give more pattern matching. And another important area is the augmented reality, AR technology. So that's again, you have the interactive experience to generate the power. So that's another area where people use that as well. So AR, use a lot in cricket. So these are sort of the applications. So the quantum system has a potential to do all this. Another important area is self-driving cars. The car companies like Tesla and all, they use this a lot as well. So these are some of the backgrounds and application. And as you all know, now we use this, the dashboard. So that's again, like for day in, day out, the dashboard application. When you have these quantum computing, that's going to become handy too. So sounds good, sounds great. We have this. So is that all? Still there are obstacles, right? One of the fundamental obstacles, if people are doing research, everything is good, but not that much study has done about that. How do you input data in the quantum computer? In the practical data, real data, right? So the real data right now, we have done enough study to just build this data. The pre-processing part and all is built for classical setup. But how do we do that is still, sort of. And also we talk about this as fast page and all, it's very good. However, the data information storage is still smaller for the quantum computing. So that's another important aspect of the quantum computing might play a role. Still the quantum computing, they have not used it in the user interface. We need to store it in the big places with the temperature wise, you need to froze the temperature. So there are so many things involved in the computing part. However, I think, right, 3 decades after they were first proposed, the quantum computing remain largely theoretical, but there is no doubt in my mind it's going to be hugely impact advances at the science of growing steadily and more encouraging quantum technology will eventually deliver the computer revolution. Having said that, one thing I want you to remember is this, right? Just don't compare the current algorithms and then think, okay, quantum computing is going to be improved that. It can, but we may have to also think quantum computer based algorithm, totally new so-called algorithm, because it's like apples and oranges. Not everything what we did here might not work over there. So always remember that, right? there is a huge area of research. So for students, the last advice I wanted to do is just to make sure that IBM and a lot of other, like Google and all, they are making available to practice you some of these quantum computing powers, so you can explore and then try to just see. And who knows, like the next 5-10 years, right, the next era become quantum computing based data science, or they call the QML, quantum machine learning, and things can go in the direction. If you just carefully use that, so no doubt in my mind, right, that's what it's going to do. So I will stop right there, right? And then again, thanks for the opportunity, and then good luck with the organizers for this, conference, and then just go forward. Thank you.
Thank you, sir. I think we have enough time for one question. Would sir be willing to answer a question from the audience if there's one?
Sure, absolutely.
Does anyone have any questions for Professor Umashanger Thayasivam? It looks like that we don't have a question, but if anyone gets a question while we are moving on, you can email them to the conference email address, and then we will, okay, I see that Dr. Artigala has a question. You may ask it, madam.
Hi, Uma.
Hi,
it was very nice to listen to a talk of this caliber. Just want to ask Uma, how quantum computing could affect the individual space or freedom or individual independence when you use it, because I saw in the sports you said it can actually monitor very minute details of at individual level. How do you think will it have any adverse effect?
Absolutely. Yeah, that's unfortunately, we are in this data science era, like with using all this, computing and every other aspects. There's no way we can avoid that. So we need to just try our best to how do we just manage that. But I don't think there's a way we can avoid that. But the only thing is, at least the quantum computer is not going to come right now immediately in a user-faced manner. It's going to be more in a research-oriented in a big site. So it might not come for an individual point of view, but unfortunately, we are in that era, like there's no way we can avoid that.
Okay, thank you, Ma.
Thank you.
Thank you, Dr. Artigala, and thank you, Professor, for your clarification. Like I said, if you have more questions, you can post them on the chat, or you can email them to the conference email. Okay. Thank you very much, Professor Umashanger Thayasivam, for a stimulating speech about various transformations the era of quantum computing is going to bring upon us. It was enlightening to learn about different impacts on the future of data science from quantum computing due to its potential to be the most disruptive technology of the 21st century. It was indeed a great pleasure to listen to you. Thank you very much, Professor.
Thank you very much, and best wishes.